Alright, so good day everyone. We are going to look at how the solubility of a solute varies with temperature, solid solute that is. Right, so we know that solubility is the mass of solute that will saturate 100 grams of solvent at a given temperature, right? So we could say that solubility can be quoted for a specific temperature. So all that means is a certain amount of solute will dissolve in a certain amount of solvent at a specific temperature, right? So let's just clear up a few things first, right? So our solute, of course, is the substance we want to dissolve. Our solvent is the substance we are dissolving the solute into, right? And when a solute dissolves in a solvent, we form a solution. Now, we know that there are factors that affect solubility, and those factors are the nature of the solute and the solvent, pressure, and temperature. Now, nature of solute and solvent was based on this term, like dissolves like, L-I-K-E, right? Not L-I-G-H-T, right? And all that means is that the same type of solute can only be dissolved in the same type of solvent. So our solutes have different structures. Different types of solutes have different types of structures. And we could classify them in either of two things. You have polar solutes and solvents and non-polar solutes and solvents. Polar solutes and solvents are solutes and solvents that have a charge, right? And a positive or negative charge. Whereas a non-polar solute or solvent does not have a charge. Now, there are exceptions to that rule, right? There are quite a few exceptions to that rule. But we are not going to look at that factor today. Pressure is another thing that affects how a substance dissolves. Pressure, however, only affects the solubility of gases. And again, we're not going to look at that today. So higher the pressure, the greater the solubility of a gas. Next is the one that we are going to investigate. How temperature affects the solubility of your solute in your solvent. So our solute is potassium nitrate and our solvent is water. So in order to do this, we have a list of instructions here which we are going to follow, right? And we're going to use this to help us to determine how solubility is affected by temperature. So first, using a balance, we are going to weigh out 15 grams of potassium nitrate and add it to a boiling tube. After we've added that, we are going to go towards our next piece of apparatus called a burette and add 10 cm cube of distilled water to that potassium nitrate in the boiling tube, right? We are then going to take that boiling tube of potassium nitrate and water and clamp it in a water bath, right? And wait for all of the potassium nitrate to dissolve. Now, water bath is simply a setup that would provide indirect heating of our substance. We don't want to heat it directly, we want gentle heat, right? So we'll be clamping the contents in that water bath. Now, after we've done this, we'll be heating it until all the solid dissolves. So we'll be looking at the boiling tube immersed in the water bath to determine when all of the solute dissolves, right? Once that happens, we'll take a thermometer, insert it into the boiling tube, and we'll completely remove the boiling tube out of the water bath, right? Using that same thermometer we placed into that boiling tube of potassium nitrate and water, we're going to stir gently with the thermometer and observe the boiling tube to determine when crystals first appear. We'll note the temperature at which this occurs and record it in a suitable table, right? Now, once that happens, we're going to add a further 2 cm cube of distilled water and repeat the whole thing. So we're going to do this around 7 times, right? So we should have at least 7 readings, right? And we'll tabulate those readings in an appropriate table. So let's get started with that. So to begin, let's weigh out our 15 grams of potassium nitrate
into our boiling tube. Now, obviously, I can't just put this here and weigh 15 grams into it. So what I'm going to do is this. I'll place a beaker here, set that to 0, right? I'll place the boiling tube, which I can also 0, right? And now I can get to weighing out my 15 grams of potassium nitrate, right? So it's at 0.01, so I could always just minus that 0.01, right? Still far from my target value. Alright, almost there. Right, so just a little bit more. Yeah, figured that would overshoot our value. No, we have excess. We don't have 15 grams, right? So I'm just going to take out a little bit, and I'm not going to return this to the container it came from. That would lead to contamination. Alright, so just a little more. Couple of granules again. Whoa, that's perfect. Okay, so we have our 15 grams of potassium nitrate weighed out, right? Remember, we just had a 0.01 there, so in order to offset that 0.01 extra, I'm weighing out 14.99. Well, the scale isn't exactly that accurate. Air pressure and stuff could affect the accuracy of the scale, right? So that's it for weighing out the potassium nitrate. So on to the next step now. Alright, so the next step is to the 15 grams of potassium nitrate, just weigh it out. We need to add 10 cm cube of water using the device there called a burette. So we need to be looking up here because you want to add specifically 10 cm cube of water, right? So measurements are usually taken going downward, not upward as usual. So it's kind of hard to see the volume readings because the background is not white. So hopefully my camera could focus on that. I guess not. Come on, a little bit of focusing is just required. Okay, there, it was there for a moment. But anyway, let's just mount this and get 10 cm cube a little bit of a tilt there. Right, so it's focused nicely. See 14, 13, 12. 10 is up there. Right. Move your tilt again. Right, now Where the camera is, you're not gonna exactly see when I add 10 perfectly into my boiling tube, simply because you'll have errors due to parallax, due to the angle at which my camera is mounted. But it's kind of hard to titrate and hold a camera at the same time, so we'll be mindful of that, right? So let's add our 10 cm cube, so potassium nitrate, and we are adding 10 cm cube to that. Right? Now when you're doing a titration where you are adding a specific volume, you are not looking at the contents in your boiling tube. You are looking at your burette and you're looking at the marking you wish to reach at eye level. If you do not look at it at eye level, well, you'll have errors due to parallax. Now, another tip when using a burette is that when you are almost at the volume of water you want, you are to slow down your burette as slow as possible, well, within reason, of course, so that you don't add more than you wish to add or that you need to add to your boiling tube. Just a little bit more, a little bit more. Right, and there we go. Now, another point to note is that when measuring volume, using whether your device is a measuring cylinder or a burette or pipette or whatever it may be, right? The bottom of the meniscus is what we are concerned with, right? So hopefully you can see that there, right? So the bottom of the meniscus must be on the line that you wish to measure. So we've added 10 cm cube successfully. Now on to the next step. Alright, so we've successfully added the 10 cm cube of water to our potassium nitrate in a boiling tube. Next step is we need to suspend our boiling tube in a water bath and allow our solute to dissolve completely, right? So we'll be focusing at the boiling tube in there, right? So let me just mold this in. Right. Right, so it's not fully immersed as yet. So just going to drop this into there. Ensuring that my boiling tube is not touching the bottom. And I'm going to shift this around so that we could actually see what's going on in our water bath. So we want to observe this until that potassium nitrate has completely melted. Now once that's done, why am I saying melted? Completely dissolved. Sorry. I'm thinking about another lab, another experiment I would have done before, right? Until it's completely dissolved. Now when that's done, I'm going to insert this thermometer into there, right? And then I will remove this and record the temperature at which that begins to re-solidify, right? So yes, it will take some time, but it's time well worth it, I think. Yes, it does take some time, so I'll probably try to help agitate things around to speed up this dissolving process. Now, take note of what I'm doing while stirring with the thermometer. You're not hearing all of that, right? Well, you hear just now, but we don't want that to happen. We don't want our thermometer to be hitting the bottom or the sides of the boiling tube during stirring, right? We want an even distribution of heat, right? So I think this is helping quite a bit, yeah. Right, so we're just trying to get it. Also, the bottom of the boiling tube will be hotter than the rest, so we don't want the bulb of the thermometer to be touching that. Right? So let's try to wash off some of that into there. Right. So we are almost there. I'm removing my thermometer because, for one thing, my thermometer will get way too hot and I don't want the temperature to be high and then it has to try to drop back down while we take in the temperature at which it re-solidifies, right? Also, another thing is we have a coating of our potassium nitrate on there, right? Because this is a cooler surface, so it's going to cool and solidify onto the thermometer, right? So we still have a little ways to go. I didn't want to use a glass rod to stir to dissolve it because of the same thing I showed earlier. I didn't want to lose any mass of potassium nitrate onto the glass rod. So that's why I use a thermometer that I will be taking the temperature readings with. Alright. Try to speed that up a little. I'll probably shoot my thermometer's temperature all the way up. But if I do that intermittently, it should work. Yeah, this potassium nitrate just doesn't want to dissolve. I know I'm breaking my rules, but I'm getting a little impatient. Just when I keep my water bath topped up a little. So down there you'll see the level of the solution. Alright. Right, all that noise should not be there, but I'm just trying to speed up this. I can't believe that took so long. And it's still going. Could probably cut off some of this. You may not be able to see, but there are still some undissolved solute particles at the base of this boiling tube. And I'm trying to get rid of, and the solid particles that you see going back in is the potassium nitrate that is solidifying back out onto the thermometer. Right, so I think we're almost there. Like a couple of grains left. Okay, I think we are good to go now. Right. So I'll just step this back a little. And I'm going to lift this completely out of here. First, I'm going to try to get some of that solid back in that I'm seeing on the side. Alright. And now we want to look at here. Now we're going to try to look to see when this starts to re-solidify, at what temperature. Right, so I'm swirling to ensure an even distribution of heat. It's currently at 83.5 degrees Celsius. $82.5. Right, so we can see that up there. So remember we're looking down here to see, seeing some crystals down here. So that's at 80 degrees Celsius. Right, so just at 80. Right, so time to record that. And we will continue. Alright, so we're gonna add a further 2 cm cube and repeat the process. Now, since it's only 2 cm cube I'm adding, I'm just going to have this flowing as slowly as possible. And of course, you want to bottom of the meniscus to be where the line is that reads for 12. So we have an additional 2. We are going to return to our original setup. And I'm going to clamp this here. Right? I am now going to return this back into here and repeat the process from just a moment ago. So again, we are looking into the boiling tube that's in the beaker. We're not looking at the water around the beaker, just to be clear, right? So we wait for that to redissolve again and continue. Alright, time to speed up this process again. Alright, so that's done. So it's dissolved. Why do I keep go back to saying melted? So I'm gonna remove this from there. And we are going to observe here. We are going to observe when recrystallization takes place. Hopefully, you can see the thermometer is a little out of focus. Not sure how to fix that. Yeah, so I figure I might need to do this then. So my mixture is at 86. Get this out of the way. Alright, that's a lot better. We could see our thermometer. We could see the mercury. And we could see when recrystallization takes place. So it's still at 82 degrees. It's at 80. Still nothing yet. Still nothing yet. Yeah, at 79. $78. $77. Yeah, if you hear all that knocking, please forgive me. It's kind of hard to try to hold this up. I have no arm strength to do this, so 76. Looking for the first signs. No, you might be seeing something that looking like recrystallization, but it's just the internal reflection of the bulb of the thermometer. 75. $74.5. 74. $73.5. 73. 72.5. 72. 71.5. I'll just keep calling out the thermometer readings in case it's out of focus on the camera. On your recording. It's at 70.5. Still no recrystallization yet. $69.5. 69. 68. say 8.5. Okay, starting to see some solid at 68. So you should probably see some tiny particles around in there. That started forming at 68. Okay, great. Now on to the addition of a further 2 cm cube. So alright, so you're gonna add a further 2 cm cube from the burette to our boiling tube and return it to the water bath. Right, so bottom of the meniscus is on 14. With the camera angle, you can't exactly see that, but I will show you that in a moment. Alright, so we've added a further 2 cm cube. So you can see the bottom of the meniscus is on the line that reads 14, exactly on the line, right? And we are going to return our setup back to the water bath. Alright, so we've returned it back to the water bath, so we'll observe when that recrystallizes once more. Well, melts and then recrystallizes. Why do I keep saying melts? It dissolves and recrystallizes. So we could speed that up a little. Right, so let's extract this once more. Temperatures are ways to go before it drops again. Now you can't see all the way up to 80, but if you've noticed from the last one, we got a high temperature of 80, then we got 68 as our next temperature at which recrystallization occurred. So from that, I will be expecting the temperature to be much lower before recrystallization occurs. So this just has to go back down to a suitable temperature. Below 68 based on the trend I'm seeing. And again, sorry if I keep saying melts when it should be dissolves. I know that could be confusing. Of course, if you were to ever try this in the future, you shouldn't be making all this noise that I'm making. You should be stirring just like this, but without hitting the sides. Temperature is still at 73. It's dropping slowly. And forgive the noise in the background. The neighbors decided that today was a good day for pressure washing. So that's 70.5. So we should be expecting solidification very soon. Let's drop below 70. Remember, we're looking at the bulb. Well, not at the bulb, we're looking in the boiling tube to see when crystals start reforming, and then we will look back up quickly to note the temperature at which that occurs. Alright, so we're officially at the previous temperature. No resolidification. We are below the last temperature we got. So it's just a waiting game. We're at 65 degrees and no signs of recrystallization. Again, just calling on the temperature just in case the camera is too out of focus to see. Right, ascendancy particles, and that's at 63.5. Right, so just to confirm, right, so you'll see, so that was at 63.5. So now we need to repeat, adding 2 more cm cube, returning to water baths, and repeat. Alright, so I'm going to add a further 2 cm cube. And that's it there. Again, remember the meniscus in the beer must be on the line that you are measuring. Alright, so it has been returned to its stand, and it's being returned to the water bath. It shouldn't take much heating for that to dissolve. Top back up. Water bath. And that seems good there. Right. So let's hope it's not as hot as before, so that temperature drop will be faster. So we'll expect a temperature that is lower than 63.5. See if I can kind of try to cool this down rapidly. Not sure if that did anything, but we can hope. Right, so we're back at the temperature that we had our last recrystallization. Hopefully that takes away some heat. There's an impurity in there. That's at 60 so far. Somehow an impurity managed to weave itself in. That's 58.5. Okay, starts to recrystallize now, and that's at 57.5. Alright, so that's 57.5. Time to add 2 cm cube of solvent again. So we're looking to add up till 18. Oh, right, that's it there. Oxidant averted. Right, returning this into our water baths. For just enough time for that to dissolve. Now that it has dissolved, we remove and monitor for recrystallization. So let's leave that in there because I know it's going to take some time. Top up this again. Now it has a little ways to go again. Yes, I know this isn't ideal practice, and yes, I know that the bottom is hotter than the top, but it's kind of like rational a little bit, because you know what to expect. Needs to be a faster way to cool this without breaking that. I am risking breaking my boiling tube. Should help cool it a lot faster. Last time it was 57.5. And which we saw crystals. Okay, so alright, so that's at 50.5. See some particles there. Alright, speeding that up was worth it. Now to add over another 2 cm cube. Alright, so let's get this going again. Last temperature we got was 50.5. Let's see if cooling will help this greatly. Just trying to cool it off without breaking the boiling tube so that we could determine the recrystallization point a little faster. So I know that the temperature for my next addition of solvent would be lower than 50.5. So I'll just be monitoring the temperature here. As soon as it drops below 50.5, I'll stop trying to cool it off quickly, like what I'm doing currently. Alright, so we could observe this now. It's below 50.5. Try to rush it a little bit again. We have one more addition and that would be it for this experiment. Right, so I'm beginning to see tiny particles there, and that's occurring at 47.5 degrees. Am I seeing correctly, or is that a reflection? No, that is correct. 47.5. I'll call it 47. That moment of uncertainty. And we're going to add one last addition from our burette. Till we reach the 22 cm cube on the burette. Right, directly on meniscus line. And I'm going to do what I did the last time and do a fast heat. So remove this retort stand because we don't need that anymore. And actually no, I will need it. Just want to quickly dissolve this. Without rising the temperature too high above that crystallization point. Alright, so that's it there. Bring this back into focus.